Hi there guys, welcome to the Practitioner prep video. So watch this kind of introductory information so that when you come back to the workshop that you can be ready to do the practice problems. So first off, we're going to kind of do some brief overview of the novice skills as well as the apprentice skills. So first off, for novice, we know that we can differentiate between horizontal and vertical. So we know horizontal transformations happen inside the parentheses. As you can see here, we're adding, subtracting inside, we have a negative inside, multiplying and dividing inside the parentheses. And whereas vertical transformations happen outside the parentheses, so we can see here adding, subtracting outside the parentheses, negative outside, multiplying and dividing outside. So we have that. Then when we went to the apprentice workshop, we were able to differentiate between shifts and reflections and compressions and stretches. So we know anytime we're adding or subtracting, whether it's inside or outside, so notice here we're adding or subtracting, we have a shift. So we're either moving left and right or up and down, depending on whether we have horizontal or vertical. Now, anytime we have a negative, we're going to have reflections. If we have a negative on the inside of the parentheses, then we're reflecting across the y-axis. If we have a negative outside the parentheses, then we're reflecting across the x-axis. And then anytime we're multiplying or dividing, we have stretches or compressions. And we'll kind of go a little bit more into detail about the difference between stretches and compressions, but generally, we know for horizontal transformations, we do the opposite. So for example, here, even though it was plus a number, we actually move to the left in the negative direction. So here, when we have a fraction, usually you think, fractions make things smaller, but we're going to do the opposite. So when we have a fractional number in front of our x inside the parentheses, then we have a stretch. My graph is getting bigger. Conversely, if we have a whole number, that makes us think of bigger numbers, but we're actually getting smaller. We're shrinking. We're doing the opposite. Whereas for vertical transformations, a fraction, we do as we're told for vertical, so everything's normal and vertical. So a fraction does mean we're getting smaller, and then a whole number does mean we are getting bigger. So make sure you have this chart copied down. Now it's a general, overview, so let's see if I can move myself. This is probably a better spot. So generally as an overview, let's practice, actually describing transformation functions. For example, if we're given the parent function f of x equals x squared, and we know it's transformed to create our new transformation graph, g of x equals x minus 7.5 squared, which of these describes the transformation? Well, first off, we know it's inside the parentheses, so it has to be a horizontal transformation. So we can already eliminate h and j, so it's either f or g. Now here, since we're subtracting and we know we're inside, we're doing the opposite. So usually subtraction makes us think negative, but we're going to do opposite. It's actually going to be positive, so we're going in the right direction. My camera might be flip for you guys. So this is actually the answer, F, horizontal shift, 7.5 units to the right. Similarly here, we're going to do the same thing. They give us our transformation function, h of x equals negative x over 4 squared. Now first off, a negative is its own transformation. So this negative, once again, is a reflection. So we're either reflecting across the x-axis or across the y-axis. So you can either think it through and think, okay, if I'm outside, I have a vertical transformation. Vertical means up and down. Well, if I'm flipping my points up and down, then I'm flipping across the x-axis. So if I'm going here to here, here to here, here to here, I'm flipping across the x-axis. So this is really a reflection across the x-axis. You can also use your chart and look back on it, and it will tell you that a vertical reflection is a reflection across the x-axis. So let's see, reflection across the x-axis, yes. Across the y-axis, incorrect. We can take out g. X-axis, good. Y-axis, we can take out g and j. So we're left with f and h. Now we have x over 4. Now we're inside, so we know we're going to have a horizontal transformation. In this case, we are multiplying or dividing, so we're not adding or subtracting, so we know we don't have a horizontal shift. We don't have a negative inside, so we don't have a horizontal reflection. But we are dividing by 4, so we know we're either going to have a stretch or compression. Now since we're inside, this is the one that's opposite. So when we're dividing, we usually think, oh, it's getting smaller. But remember, it's opposite. So we're actually getting bigger. So this is actually a stretch. So a reflection across the x-axis and a horizontal stretch. This is correct. Now if you had looked at your other answer choice, a reflection across the x-axis, yes, but this tells us it's a vertical stretch. Incorrect. We know it's horizontal just by knowing it's inside the parentheses. So if you still can't differentiate between is it a stretch, is it a compression, you could at least know it's a horizontal transformation. So the only option available is answer choice F. The last thing I want to go over is in the practitioner workshop, we're going to go over stretches and compressions, graphic, or how it looks on a graph. So generally, the way we think of it is, okay, let's think of vertical stretch. So let's say we have a rubber band. If we're stretching something vertically, so here's my original rubber band. If I'm stretching it vertically, notice it's getting more narrow. So vertical stretches make our graph more narrow. Conversely, if I'm stretching it horizontally, notice my rubber band is getting wider. So vertical stretch make my graph narrower, horizontal stretches make my graph wider. Then we go into compressions. So compressions is making things smaller or kind of pushing it inwards. So we have a horizontal compression and I push it inwards horizontally. Notice what's happening to my graph. It's becoming more narrow. So horizontal compressions make my graph narrower. Versus if I'm doing a vertical compression and I'm pressing it vertically going up and down, my graph is becoming wider. So I realize I didn't label these, but just think of it as a rubber band. Horizontal compressions make my graph narrower. Vertical compressions make my graph wider. And we'll practice this more in class. So I'll see you guys in the Practitioner workshop. Now if you want to prepare ahead, here are the questions you're going to see. So you're going to be given this function and say, okay, match it to the correct graph. You're going to be given this function and say, okay, which of these statements is true? And you're going to be given this graph and say, okay, which of these statements is true? So if you want to kind of pause and go back and look at these questions and kind of prepare ahead of time, feel free to do so. Otherwise, I will see you guys in check-in 3.